Hi all, this is lecture 26. We're talking about 7.2 on trigonometric equations. Okay, so up to this point, we were saying, okay, let's find the trig function of a particular angle. Now I'm going to give you the value of the trig function and you have to tell me the angle. So we're kind of working our way backwards. So we're just going to work through some examples here. We're going to start with sine x equals 1/2. So in this case, what I'm looking for is I'm trying to say which angle x gives me 1/2. So which angle has opposite side 1 and hypotenuse 2, okay? Well, we can think about here, which one of our triangles does that, right? Well, our triangle that has a hypotenuse of 2 would be the 30, 60, 90. So 1, if I want to put the side 1 opposite, that's this one, and that makes this the square root of 3. So this must be the 30 degrees, okay? So 30 degrees or pi over 6 if we're converting to radians. But when we go backwards, if we're thinking about how many angles we can do in, that's one solution, right? But how many times in 2 pi can we get that answer? You can actually get it twice because the sine is positive 1/2 in 2 different quadrants. So it's positive 1/2 here. This is our 30 degrees, right? But sine, C-A-S-T, sine is also positive over here. So if I use 30 degrees as a reference angle over here, then the full angle is 180 minus 30, which would be 150 degrees. So my second angle would be 150 degrees, or let's see, we're going 150 over 180. So it's going to be something over 6, right? 150 over 180 is 5 of pi over 6. Okay. And so I get 2 answers. So I get 30 and 140, or pi over 6 and 5 pi over 6. So when we're solving an equation, and if typically what we're going to be going is from 0 to 2 pi, right? So how many times in that angle do we get a value? We could then say, okay, well, each one of those happens, and you can get that angle, coterminal angles, by adding or subtracting 2 pi every time. So in general, you could then say that you would get pi over 6 plus 2n pi. So I can go around however many times I want, right? And so n could be positive or negative. So if n was 1, you'd take pi over 6 and add 2 pi, right? And our second solution would be 5 pi over 6, adding 2n pi, right? Because that's how you get your coterminal angles. So this is what would be our solution in general. So if we're only in the interval from 0 to 2 pi, then we're going with pi over 6 and 5 pi over 6. If we're going in general, we're just going to add 2n pi to those. Okay, let's take a look at this one. Now this one's very similar, only now we have a 2x sitting right here. So what I'm going to think about first is I'm going to say, let's not work with 2x, let's work with y. So let's find the cosine of y. So I'm letting my y be that 2x. Okay, so when is the cosine of y equal to 0? Okay, well, for 0, the value of cosine, that's going to be one of our corners. So I'm thinking unit circle here. And cosine is the first coordinate when we're on the unit circle. And so that is 0 up here and down here at 0, 1 and 0, -1. So that happens, so y is equal to, at the top we're at pi over 2, or 90 degrees, and at the bottom we are at 3 pi over 2. Okay, now here's the thing. What we want to do then, those are my y's. Now, substitute back in. Your y is equal to 2x. So 2x is equal to pi over 2, and 2x is equal to 3 pi over 2. Then we're going to go ahead and divide by 2 on both sides. That's going to give me pi over 4 and 3 pi over 4. Now, we have to be a little bit careful here if we're doing in general. In general, so these are our 2 angles, and we're actually going to get a couple more yet, because what happens is we're going to take this and make it 2x equals pi over 2 plus 2n pi. Then we divide everything by 2. Then we get pi over 4 plus n pi. And the same thing on the other one. So x equals 3 pi over 4 plus n pi, if we did the same thing. So this is our solution in general. So if we're thinking what's happening between 0 and 2 pi, so you've got pi over 4. You've got 3 pi over 4. Then if I add pi, now notice, if I make this n 1, then I get 5 pi over 4, right? Because you're adding 4 pi every time. So that's going to give me 5 pi over 4. And that's still less than 2 pi. And if I take another one from down below, if I let this n be 1, then 3 pi over 4 plus 4 pi over 4 would give me 7 pi over 4. And all of those are within 0 to 2 pi. Okay, so what happens is when you have a 2 in front of the x, you're going to get twice as many solutions within that range. Okay, so essentially it's doubling your number of solutions. If I had 3x, I'd get triple the number of solutions. Okay, so watch out for that. All right, now there's some other techniques we can use here to solve when we get to number 3. Notice that I have a sine x on both sides, and I don't have any numbers to work with here. So what we're going to do is we're going to put everything on one side so that we have a 0 on the other. So let's go ahead and subtract a sine x here. And that's going to give me sine x tangent x minus sine x equals 0. And then if I'm going to solve this, think about them as variables. I have a sign in both terms. I'm going to factor that out to the front. And I'm going to be left with tangent x minus 1. Now, because this is equal to 0, then I can set each piece equal to 0. So that means that sine x is equal to 0. And tangent x minus 1 equals 0. Which means tangent x equals 1. So now I'm really solving 2 equations, okay? So let's start with the sine of x equals 0. When we get zeros for sines and cosines, we're thinking where on my unit circle, right? So cosine x, then sine x. So I'm looking where is the second coordinate 0? That would be here and here. So that is when x equals 0 and when x equals pi. Okay. And of course, we're adding n pi each time. So 0 plus n. So x is equal to 0 plus n pi. And that actually captures all of it, right? So because if we took pi plus n pi, that's just, if we let n equals 1, we get pi, right? So I can stop there. So those are solutions. Now, if I go over here for tangent x equals 1, okay, tangent x equals 1, this is opposite over adjacent, right? So I need the opposite and the adjacent side to be the same. So that's going to be our 45, 45, 90. Okay, so that means that x here is going to be pi over 4. Now, we want to think about where we want to put it so that the tangent is positive. Tangent is positive 1 here. So we put 45 here. And tangent is positive, C-A-S-T, in this quadrant here. So 45 degrees over here. And then if we're going all the way around, that's going to be 180 plus 45, and that's going to give us 225. And if we convert 225 to radians, we get 5 pi over 4. So my two values are 5 pi over 4. And then, of course, plus or minus n pi. So x is equal to pi over 4 plus 2n pi. And x is equal to 5 pi over 4 plus 2n pi, right? And these are the general solutions. If they were looking for the ones with just from 0 to 2 pi, I'd have 0, pi, pi over 4, and 5 pi over 4. Okay. On to number 4. Okay, now we're specifying here that we only want to be on the interval from 0 to 2 pi. All right, let's see what's going on here. Again, take a look. I've got something equal to 0. I have a tangent here and a tangent here. So I'm going to go ahead and factor that tangent out to the front. And I have 4 sine squared x minus 1 equals 0. And I can factor what's in the parentheses one more time because that's a difference of 2 squares. So this is 2 sine x minus 1 and 2 sine x plus 1. That's going to give me 3 equations to solve. So tangent of x equals 0. 2 sine of x minus 1 equals 0. And 2 sine of x plus 1 equals 0. Let's take these one at a time. So for tangent of x equals 0, whenever we see zeros, we're thinking it's got to be on a corner. Okay. Now, tangent is the same as sine x over cosine x. So we need to know when is the sine equal to 0, and that would be the second coordinate, and so that happens here and here. So tangent is 0 when x equals 0 and when x equals pi, right? And now we're not going any further than that, so we're going to stay just with those two values, right? Because we're stopping at 2 pi. On to the middle. So if I solve this one, let's add the 1 and divide by 2. So that's when sine x equals 1/2. This was the exact same question we did in number 1. So sine of 1/2 tells you you're going to be in the 30, 60, 90 triangle. And this is your opposite over the hypotenuse. So 2 and 1 means that this must be 30 degrees. So that's going to give you pi over 6. And then we've got to put it in the right quadrants. So I'm putting 30 degrees here and C, A, S, T. Sine is also positive over here. So I'm putting 30 degrees over here. So that's going to give me all the way to here, 180 minus 30 is 150. And if we convert 150 and divide that by 180, convert it to radians, that's your 5 pi over 6. So we get two values from the middle one. And then over here to the last one, subtract your 1, divide that by 2. That's going to give you sine x equals negative 1/2. Okay. Well, the 1/2 value tells us we're still going to be working with a reference angle of pi over 6. But now, because it's negative, we're not going to put it in the first quadrant. We're going to put it in the quadrants where sine is negative. So C, A, S, T. Sine is negative here and here. So that's going to give us, and we're making it 30 degrees. So this one, all the way around, is going to be 180 plus 30, which is 210. And if we convert 210 to radians, 210 divided by 180, reduce your fraction. It's going to give you 7 pi over 6. So x equals 7 pi over 6. And then we also want this one to go all the way around. And that's 30 degrees short of 360. So 360 minus 30 degrees gives us 330. And let's divide that by 180 and reduce your fraction to convert to radians. So we get 11 pi over 6. So we get 6 solutions to number 4.